Hello, let's continue our Sudoku adventure with Sequence of Events by DJV. So we have normal 6x6 Sudoku rules in every row, every column, and every 2x3 box. We are placing the digits 1 to 6 exactly once each. We also have sequence lines in the grid. Those are these gray lines here. Along the gray line is a sequence of digits in order with a constant difference between adjacent numbers, and each line may have a unique difference. So let's say there was a difference of 1, we could do say 1, 2, 3, 4, and that would work fine. But we don't have to start at 1. We could go 3, 4, 5, 6. We could also go the other way. We could go 1, 2, 3, 4. So we don't know which way it goes, but we're going to have a constant difference in order. Could also have a difference of 2, but I think you're going to struggle a little bit with that because there's no 7 in 6x6 Sudokus. So I think we're going to be stuck with a difference of 1 in a 6x6, kind of giving that away. But anyway, those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. So yeah, I do believe these do have to be consecutive because we're not going to have like 2 times 4 is 8, right? We're going to have a difference of, how would we want to think about that? If this was a difference of 2, then a difference of 4, then a difference of 6, these would have to be 6 apart. And they can't be because you can only have 2 digits 5 apart in a 6x6. So we are going to have a difference of 1. And I think that matters for this line because the 2 sees this whole line. So we can't do 1, 2, 3, 4, 2, 3, 4, 5. So we're going to do 3, 4, 5, 6. And this is a quad. So any other cell that sees all 4 would see the whole quad. Like, oh no, I don't think there is a cell like that though. So this is either, but it can't just be 3, 4, 5, 6. Like this has to be one of the ends. These have to be the ends and these have to be the middles. So we should keep that in mind. So this sees a 4, 5 pair now. So these need to be consecutive and can't be 1 or 6. So they have to be 2, 3. And that makes this a 1, 4. Okay, and this is a 1, 6 pair. 1, 6 always had to go here because these could never be 1 or 6 in the middle of a sequence. So maybe that's something to think about down here as well. Yeah, this is also a 1, 6 pair. So these are consecutive and these are consecutive. So we're going to have a 2, 3 and a 4, 5. I'm thinking this can't be 4, 5, but I'm not entirely sure why. It just feels like it shouldn't be the same as this line. But let's see. Where does 2 go? I don't know if that's the right question. I think it could be 4, 5. I was thinking about uniqueness and how that would make a unique rectangle, but I think the sequence line can break the uniqueness logic. So we need to be careful. Okay, where does this cell, let's color this. This is green and this is purple. These are a pair, right? So where does green go in this box? Green goes over here. Darn, I thought I was going to place it here, but I just realized I can go in either of these. But this can't be 1 or 4 or 2 or 3. So this is 5 or 6. Because it sees the green purple 1, 4 pair and it sees the 2, 3. This is a 3, 6 pair, so we could do blue and orange for that if we want to. So where does blue go? Blue goes in one of these two. Darn. Does that help? Blue is on here. I see. So we have a 3 or a 6 on this line. If it was a 6, it would go here. And it would be 6, 5, 4, 3. That actually seems reasonable. If it was a 3, we could go 3, 4, 5, 6 also. Or if this was a 3, we could go 1, 2. We can't go 1, 2, 3, 4 because of the 2. So we'd have to go 2, 3, 4, 5, and that doesn't work. Oh, interesting. So blue never goes here. So let me go over that a bit more carefully. Let's say blue was here. That would make this a 3 or 6. Well, we know 6 can't go in the middle of the line, so it would have to be a 3. And if it was a 3, how are we getting to 3? Well, we're either going 2, 3, 4, 5, but if we do that, that breaks this column because there's just too many 4, 5s in the column. So we'd have to go the other way. We'd have to go 1, 2, 3, 4, but then we can't place the 2. So this can never be blue. This is blue, and it's a 3 or 6. If it's 6, we're going 6, 5, 4, 3, which seems to be okay, because this would be 6, 5, 4, 3. Or it's a 3. We can't go 3, 2, 1, nothing. So we'd go 3, 4, 5, 6. And that gives us a 3, 6 pair. It gives us a 4, 5 pair. So it is, I was trying to prove this couldn't be 4, 5, and I ended up proving it had to be. So this is a 2, 3 pair for the row, which makes this a 1, 4 pair. And we can make this purple and this green. Don't know if we need to, but we can. We can also make this one orange. All right, so maybe the coloring wasn't needed, but there we go. This is a 5 or 6 for the column. I think the coloring isn't needed anymore. Let's get rid of it. Okay, so because we just have pairs in the columns and rows and such. We have all these pairs, so we're going to need a 5 and a 6 here. That leaves a 2 and a 3 for this column. So this is a pair. This is, we have 1, 2, 3. We need 4 and 5. Something going on here. This is a pair. This is 1 and 2, which means this is a 4, 5 pair. How is this resolving? Aha, we need 2 and 3 in this column. This 2 resolves it. So this is the 3 and this is the 2. That makes this 6, 5, 4, 3. That makes this 6, 5, 4, 3. That makes this a 1, 6, 5, 4. All right, we're getting all of these digits. 4, 3, 2, 1. 4, 3, 2, 1. Very nice. Okay. And a 1. All right. Well, cool puzzle, DJV. Unfortunately, sequence lines of a link 4 at least only can be a difference of 1 in a 6x6. In a 9x9, you have a lot more optionality. But so be careful about that if you do encounter sequence lines in a 9x9, that you can get up to 9 in those. But yeah, cool use of sequence lines here. I appreciate that. I hope you enjoyed this as well. And if you did, then why not leave a like, subscribe, and a kind comment below.